So in the beginning, this can be one particular consideration for selecting the inner and the outer pipe. Even if you haven't done, you can switch it. The other thing is definitely, see, you can have several arrangements of parallel hairpin heat exchangers for this. For example, in this particular case, if you find, you will find that the shell side fluid, it is connected in parallel, sorry, in series, and it goes on. But the tube side fluid, it has been divided into half, and uh, each particular half of the tube side fluid is flowing through one particular hairpin. This also you can think in case the pressure drop limitations are not satisfied. This is see, the advantage of double pipe exchanger is that you can arrange them in different modules. You can have different series parallel arrangements and you can go ahead. In fact, if you are referring to the book of Sarth, I would suggest just look at the worked out problem at the end of the chapter on double pipe exchanger. It is a very interesting problem of how the pressure drop limitation was not satisfied and what are the different options that they had used. Finally, they have used a combination of different options in order to satisfy the pressure drop limits and also to minimize the area of heat exchange. In fact, I find that to be an extremely classical problem. I would suggest all of you, even if it does not pertain to this design, see, I am a very considerate, or rather we are very considerate clients, so definitely we do not have not given a very complex design. But definitely, I would suggest you go through the book, the worked out example in the book by Sert. It will give you an excellent idea on how the two fluids, how they can be arranged, what are the different options to satisfy both the requirements of minimum area as well as pressure drop limitations. That will give you a very good idea. I believe it's a problem. The flow is aniline and something else possibly. They have tried several options, I think 3-4 options, and then finally they have arrived at some particular arrangement of the hairpins, and along with that switching of fluids, everything they have done. So go through the problem. It will give you a very good idea of how to actually handle such situations in practical cases in industrial situations. But for the time being, have any of you calculated the pressure drop by any chance?
Mostly, like I got stuck at friction factors itself.
5, because see, friction factor is 16 by RE, means where was the problem exactly? That is what you were not
Like,
happy to take it or something else.
no, ma'am, in
Ma'am,
the
for the
transition,
turbulent zone, it was
What
for the
happened?
for the turbulent, it is 16 by RE, but for
Hey,
transition, there's
क्या हो गया? For turbulent flow, it is 16 by RE.
no, ma'am. For laminar, it is 16 by RE, but
Perfect, perfect.
for,
for
we were not having the formula for a transition zone.
Acha, wait, I will upload a document where you will get the formula. But the point is, if you are going through the book by Sart, that has given you a formula for transition. Just refer to that formula. Okay, but give the reference of the book. I'm happy that you're referring to the book by Sarth. In fact,
ma'am,
I find the book to be better than the book by Shah. That is true. Yes, please.
ma'am, also in both the book TQ Khan and RW Sharth, we can't find the viscosity for kerosene. Like the X and Y we plot and we get the viscosity. Like, like if
What
I
have?
can just
Listen,
like
listen. Ah,
I will upload the screenshot.
ah. Kerosene viscosity, Professor Kostavray, are you there? I think kerosene viscosity is available. It was given in the problem possibly, and it is also there in Khan, isn't it?
Ma'am, like I have uploaded a screenshot in the
Where, where, where do I go to see it? Can you
in
not
the
share it here? Okay, I'll stop sharing. Wait.
in the chat, ma'am. You can see option next to participants.
Next to participants. Wait, wait. Arey babri. Huh. Let me
Ma'am,
see. Yeah. Yes, yes.
yes, ma'am, like I have like the X and Y values for kerosene are not mentioned. So as to consider for viscosity, that is
So
it.
what to do in that case? If it is not mentioned, then what do you do? You
Like I
tell
have
me.
I've
Yes.
taken the value that is mentioned in Google.
Perfect. You have to give me the reference. That is it.
Okay, ma'am.
Okay.
Yes.
But just check up. It must be okay. But just check up in any other chart. Just refer to Perry once. If you have taken it from a reliable site of Google, I have no problems. But tell me one
Okay.
thing. Was the value not given in the problem? Isn't it? The kerosene viscosity?
No, ma'am, it
Yes.
wasn't given.
No, no
I
problem.
that
You can see. You can also take up. Yeah, from the Google, you can highly take up the kerosene viscosity. What is the viscosity that you have got?
for kerosene it was around for gas for kerosene it is 1.4 cp.
1.4 cp. Is it
Yes,
more
ma'am.
viscous than water? That means. And just give me 2 minutes. Let me see the problem statement.
Kerosene is there in the current book on page number 821.
Exactly. Kerosene has to be there. Kerosene has to be there. Just go and have a check.
Okay, ma'am.
Wait.
Like
Kerosene has
not
to be there. It's very, very common. In fact, see, 42-degree API kerosene is there. You have to refer to this API, and then I think if you go to I don't know, page 806 of Kern, there no, that is for CP possibly. Just check up, but viscosity will also be there in the book by Kern. You must be getting it. In fact, in the book by Sarth also the viscosity should be there.
Yes, ma'am, it is there in the XY for kerosene 42
Uh,
degree API.
Perfect. See, you consult among yourselves, half your doubts will be sorted out. Okay. So therefore, go ahead. And any other doubts, anything else? Go ahead. See, the design normally is not at all difficult and it should not be iterative. Regarding the viscosity correction factor for kerosene, gasoline, they are low viscous liquids. There should not be a problem. For seawater also, it should not be a problem. For engine oil only, you might have to check up. What I suggest is you can, even if you do not get it anywhere else, you can refer to the chemical engineer's handbook by Perry, and there you will find mineral oil. You can take up that particular viscosity. I think for this small temperature range, the viscosity correction should not come up. But you just mention this. If that is not there, then there is almost no iteration at all. Okay. You can go ahead, select the pipe diameter. Do not select a very large pipe, but select an optimum, not less than the minimum permissible that has been mentioned, and go ahead. If you are having laminar flow, go ahead with laminar flow. And for your transition region also, Sarth also provides a formula. I do not know, I do not remember whether in my slide there was a formula or not. I'll be uploading a handout where the yellow highlighted portions are not very relevant for you. The other portions will be relevant. In fact, in that particular handout that I'll be uploading, possibly the steps of design are also given. The steps of design are also given in the slides that I had uploaded. Okay, or I'll be uploading once more now. So there the steps of designs are also given. So you can just follow those and you can do it. I think it should not take more than 2 to 3 hours to complete this particular design. So at the end of the class, we will see if the pressure drop constraints are satisfied. Then you need not have to bother. If not, then you have to make some suggestions. And in the next class, you have to submit the report along with the drawings. So I'll be uploading a handout and I'll also be uploading the revised slides where the formula for pressure drop, etc. will be given. And the friction factors are also given. Friction factors for all ranges are available. If suppose you are getting something like 7,900 or something, then in that case, you can increase the velocity a little to ensure that it is turbulent flow. Otherwise, you can go ahead with whatever you have got and you can complete the design. That's not a problem. right? Any other doubts? Anything else?
And ma'am, what should be the length of hairpins? It should be 16 feet or 20 feet?
See, normally 6 meters to 6.5 meters are standard bought out pipe lengths. Okay. So therefore, I would suggest that you take something between 6 to 6.6 meters or 6.5 meters, not longer.
Okay, ma'am.
That is
Ma'am,
there.
ma'am,
Yes, please. Yes,
ma'am,
please.
I have found in the internet that we can use hairpins from 2 to 30 feet size, in feet sizes, inch sizes.
Once more, I could not hear. For in meters, can you convert and tell me?
Ma'am, it's around the longest which was mentioned in the internet was 13, so it was coming around 9.144 meter.
Yeah, see, normally you can go, but normally standard bought out pipes are around 6 to 6.5 meters in length. So therefore, I would prefer to keep it that way. Okay, because then I can just buy the pipes from the market and I can start fabricating it. But
Okay.
hairpin exchanges can be longer as well, definitely. But just refer to the internet and you can find out what is this. It's usually 30 feet possibly. I don't remember.
Yes, ma'am. The
Yes,
maximum is 30.
maximum is 30 feet. That is true. So therefore, see, that is the maximum possible. But you also have to keep in mind that more or less if it occupies a very large amount of, say, floor space, it is not going to serve any purpose. Okay. And instead of 6 meters, if you're going to 9 meters, maybe one hairpin you will be saving. Whether it is worth or not, that is also a question. So, but anyhow, if with the proper reference, if you go ahead, I have no problems, right?
Okay, ma'am.
Normally
And
they are 6 to 6.5 meters. That is what we prefer. And but if really you would like to use longer tubes, I do not know if you can justify the savings in cost by some way. I'll go for it.
okay, ma'am.
Anything with a logic, I'll go for it.
Ma'am, the length that we found after calculations, we got a length about 200 meters. So is that feasible to is
See,
that
if you
feasible
have
to
got
construct?
it, if the I do not know about the correctness of the calculations, right? That you have to check. But other than that, if it is 200 meters, is it really feasible? I do not know. Okay, how many hairpins is it coming to?
It's more than 15 hairpins. If you take
1.5 or 5.0?
it's like 1.5. I don't remember the exact length that we got, but it was coming about more than 20 hairpins, I think.
Yes,
Normally,
ma'am. For me also, like the length was coming around 400 meters and number of hairpins were 32 approximately.
just check up the calculations. It should not be that, but just check up the calculations. If it has come, then we cannot help it. Then in that case, I do not know what will happen to your pressure drop. Okay, so that part also you have to find it out. And if you are referring to the book of Sat, they give you a limit of the maximum number of hairpins. In fact, the handout which I'll be uploading, that's a part of the book that we have written recently. So there also you can find out what is the maximum number of hairpins. Generally, that is permissible. But I do not think if you have done the calculations correctly, if you have taken all values correctly, then this should not lead to something such an infeasible amount. This should not happen because the flow rates are quite low, I believe. So this should not happen. If the hairpins are very long, the one thing you can do, you can increase the tube diameters. You can go for a larger tubes. Okay, see that those part you have to optimize. So
Ma'am,
therefore, yeah.
yeah, you mentioned that 2 to 4 inches is typically what we use, right? But can we use a tube which is larger than 6 inches, say for example?
Larger than 6 inches feather width. I'll just mention what is the tube size that normally, just me check up. Normally it is 2 to 4 inches and with the inner tube and now outer tube, and this is 3/4 to 2.5 inches. But if it is absolutely required, you can go for larger diameters. But again, if it is too bulky or something, it will not be very proper. So see if, what is the tube diameter, the inner tube diameter that you have selected?
2.469 inches, I think.
2.5 inches.
Yeah.
In that, are you getting so many hairpins?
Yes, ma'am.
Check your calculations. There's something wrong, I believe. Just check your calculations.
Okay, ma'am.
Okay, because as far as I know, the flow rates are quite less. So this should not be, and the temperature differences are also not very high. If you have checked up everything and if you're getting this particular value, I have nothing to say, but just have a proper check of the value of U that you have taken. Check up everything. I do not think this should happen. You can also refer to the TA. The TA should have done the problem. So therefore he or she will be in a position to tell whether this is feasible or not. Refer to the concerned TA who is assigned to your group. Okay.
Okay, ma'am.
Any other doubts?
Regarding the submission, does everyone in the group needs to submit the report at the process?
No. One report per group.
Okay, and is that according to the smaller groups or the larger groups in the Microsoft Teams?
What does it mean?
I believe like there is a group division in the page.
3 people. Hey, just hold on. In the Microsoft Teams, it is because of the limitation of 30 channels, we placed 2 groups in one channel.
Okay.
But groups division is, you know it. I mean, I have already submitted that document. I think
Okay,
it is
got it.
people in one group.
Okay, got it. Thank you.
So therefore, each group one report. That is all. And the report should contain all the details which will be required for fabrication and the logic for certain selections or certain not selections. The logic should be there. And regarding the values, regarding whether it's feasible or not, definitely you refer to the handout which I'll be uploading, or it's better still if you can refer to the book by Sarth or Shah Sekulik, anything. You find it out. And suppose something infeasible comes, then in that case, you have to provide certain solutions such that which may be adopted for an optimum design. But I believe such a situation should not arise. If you are getting so many hairpins, then definitely the pressure drop limitations will not be obeyed. So I think there is some mistake somewhere that has been made. Just check up once more, and then your TA should be in a position to help you on this. So refer to your TA and find out what has to be done.
Yes, ma'am.
Okay. Any other questions? So if there are no other questions, then I am there online. But first you have to discuss your problems with your TAs, and then only we can take it up with me or any of the other faculty members who are present here. Okay. And in the meantime, I'll be uploading the slides. I'll be uploading a handout. You can refer to it. And you can also refer to the book by Sarth or Shah Sekulik, anything. For physical properties, I suggest Kant should give you everything. In case you are not getting anything in Kant, Perry should suffice. I do not think you need that much, but by this, I think you do not need anything else other than this. Okay, then.